Hi VB students, let's do some exercises off of Tracing Functions worksheet number 1. On this worksheet, you're supposed to imagine that you have a bunch of labels on your form right here, numbers 1 through 10. And they correspond with the lines of code over here to the left. So number 1, this is just an easy one. 10 times 10, that's 100. And because assignment statements work from right to left, that 100 is assigned into the text property, a label 1, and therefore a 100 shows up. Okay, number 2. This is a function call. We are calling a function. It's not a method, as we'll soon see, but it's a function. And 10 is being passed as a parameter down to the function compute area square. So we have to scroll down in our code window to find the function compute area square. Right here it is. Don't be confused here. Instead of private sub, functions are started out with private function. And this is the important point. The name of the function is right there, and that does match compute area square in the call, function call up there. And that 10 just knows to plug in for the parameter width. The word by val, we're not going to go into detail as to what that really means. It's sort of like the word dim that declares local variables. In this case, it's a parameter, so just generally speaking, ignore by val. And as integer is here, just because it has to be here, it's telling the computer that width is an integer. And yes, 10 is a whole number, so that's fine. So kind of ignore that also. So 10 plugs into width. In a way, you can think of width as being a variable. And so I'm just making a little note on my scratch paper here that width is currently equal to 10, because that 10 was passed to it. This is called passing a parameter. And in the body of this function, we take width times width, which is 10 times 10. That simplifies, of course, to 100. And that 100 is then returned. This acts as if there's a set of parentheses here. You always do the arithmetic first, and then you return whatever you're left with. Well, a return statement takes the number that's simplified there, evaluated, and it returns it back up to where you came from. In this case, the function call, compute area square parentheses 10, has now just been replaced by 100. In other words, 100 is now being assigned into label 2's text property. So we also get 100 as the answer here. Same answer, but just a different way of arriving at that answer. In exercise 1, we just multiplied 10 times 10. Here we have a function that is passed a parameter, and then the function returns a value back to the function call. This is the better way of doing things in most cases, because this function, compute area square, can be reused later on in the program. And if you really know what you're doing, you can use this function in other forms, other projects. So you can really take advantage of the reusability of functions. If you hardwire things with just 10 times 10 on a line of code like this, you're not going very far in computer science or software design, because you'll have to redo so much stuff that you could have reused. Okay, let's do number 3 here. Number 3, we have a function called compute perimeter square, and we're passing the parameter 5. Let's scroll down and find it. Oh, here it is, compute perimeter square. That 5 gets passed and plugs in for width. Now what a coincidence. We used the same parameter name here in this function. Well, it's really a whole different copy of a parameter width. It has nothing to do with this width. In fact, as soon as we hit the end function and this function was finished executing and we came back up here to execute the rest of the form load method, this variable, this parameter, no longer exists. Its lifetime is over, as we say. Now in this case, because we are now calling compute perimeter square, we have coincidentally another parameter named width. We can ignore the by val and the as integer, and this width is equal to 5. And what are we doing with the 5? Well, we're taking 4 times 5, which course, is 20. And that 20 is being returned back up to the method or function that called the function compute perimeter square. So we're sending the number 20 back up here, and it's plugging in for this function call right here where we passed the 5 from. We're returning a 20 to that spot. So it's all boiled down to just the number 20, and the 20 is being put into the label 3 text property. So we have the answer of 20 over here on our worksheet. Next, we're calling number 5. Number 5 here on this worksheet is asking you to fill in the blank in the compute area rectangle function below. So let's scroll down and find out what's going on there in the compute area rectangle function. By the way, functions, they're usually named with a verb because the purpose of a function is to do something, and it indicates like a verb, an operation. So compute area triangle, rather than just the name area triangle, is filled in. I'm sorry, I'm doing the wrong function. We should be analyzing compute area rectangle. It has a blank line there, so you're supposed to fill in something that would be returned. Well, notice the names of the parameters. Length and width were given to us. And you all know that the area of a rectangle is width times length. So, or length times width, it doesn't really matter. So length star width is the answer here for exercise number 5. These parameter names can be anything you want them to be. It could be L and W, although that's not very descriptive, and therefore we don't like single letters as variable names. So better names are length and width. Okay, exercise number 6, you're supposed to compute area rectangle. Well, I'll fill you in on a little secret here. If a programmer names his or her function appropriately and has a logical number of parameters in the parentheses, anybody with basic knowledge should know what that function returns without having to trace the code. So without taking this 10 and the 4 and passing them down to the body of the function, we should just know that, well, the area of a rectangle is length times width, and one of these two is probably the length and the other one's the width. So the answer is probably 40. And whoops, I skipped number 4, so you can do that exercise with the 5 and the 8. But let's follow through with this and see if the answer really is 40. Let's pass the 10 and the 4 down to the function compute area rectangle. Here goes. 10 is the first parameter in the order of things with the comma, and 4 is the second. So I'm scrolling down. I'm looking for the function named compute area rectangle. The order of these functions that they're typed out in doesn't really matter. As long as it's spelled correctly, the computer will find the function. Here it is, compute area rectangle. It's the one that we filled in a second ago. And I believe it was a 10 and a 4 that were passed down here in that order. So the 10 plugs into length, and the 4 just knows to be plugged into width. If you had a third parameter here with yet another comma, there could be problems. I'm not going to promise that there are errors. It depends on what situation, but it's beyond the scope of this class that I'm teaching right now. Usually, you have the same number of parameters in the parentheses of a function call as you do in the function header. The first line of the function is called the function header, down below. So the 10 and the 4 do match up, and 10 times 4 is 40, and this 40 is returned back up to the call statement, and therefore we do indeed get a 40 here as an answer. I have another version of compute area rectangle called version 2 with that as part of the name. Let's scroll down and take a look at how that's different. In this version of compute area rectangle, we have a local variable named result. It's being dimmed or declared here, so we need a little column for it to keep track of it. It begins with a 0 stored there, but assuming that we're passing a 10 and a 4 here, The 10 and the 4 plug in for length and width. And because 10 here times 4 is 40, a 40 plugs into result. And therefore the 0 is overwritten and a 40 should now be placed on your scratch paper. And now we get to the line of code return. I think what we want here is return result, so please fill that in. And that variable result, which is 40, at 40 is now returned. What's the difference here between this function and this function? They both compute the area of a rectangle, and they both take two parameters. Coincidentally, the names of the parameters are the same. And they both return integers. I glossed over it here, but out here to the far right, after your parenthesis here that have your parameters in them, you need as integer or as double. If you're returning something that could be like 0.5, like the area of a rectangle when you divide by 2, you could get an answer of like 0.5. If it could be a decimal number, you should always type as double when typing out the body of a function. If you're guaranteed that you have a whole number, then you can type as integer. You do have to type something, and it's usually either integer or double, at least at this point in our course here of study. Well, what I was really driving at a second ago was the difference here between these two versions of compute area rectangle is that this version down below has 3 lines of code in the body, and this version only has 1 line of code. 1 versus 3 lines of code. This version uses an extra little local variable that only works inside of this private end function. You cannot messagebox.show result anywhere else in this code window. You cannot try to use result anywhere else because it's only dimmed, it's only brought to life and declared in the body of this function. So it's kind of like a bread plate where we're storing our bread on this little small plate while our main course of our dinner is on another big dinner plate. It's just an extra little plate that you use when eating your meal. The food still goes to the same place, your stomach. How you break it up into short steps with 3 lines of code, that's up to you. If you want to cut your steak into 3 pieces and versus 1 piece, assuming that you don't choke or something, this is quite fine. I will not take off points in this course for somebody who uses 3 lines of code to do something that another student does in 1 line of code. We are not using significantly more memory on the computer when doing it this way. Temporarily, we do have an extra variable being used, but its lifetime ends a microsecond later when it hits end function. And behind the scenes, Visual Basic and other compiler software often compacts things that are 3 lines of code into 1 line of code, or actually, conversely, they take what you think is 1 line of code, and behind the scenes, it's broken down into 3 lines of code if you really examined the binary that executes behind the scenes. So it's just a matter of style, and I really don't care which version in this first beginner's course you would use. The version with 1 line of code or the version with 3 lines of code. Hopefully you can do the rest of these exercises on your own here by filling these in. I'll just stress here len plus 1. Because that's inside the parentheses, len, which is 6 at this point, 6 plus 1 is 7, and wid, which is 8 because of this line of code here. 8 times 2 is 16. So because you have a 7, 16, 7 and 16 are passed as parameters to the compute area rectangle function. You must do the plus and the multiplication here before you pass your 2 parameters.